There is a building material that has been standing for 2,000 years without a single repair. A dome built before the birth of Christ still holds the record today as the largest unreinforced concrete dome on Earth. Meanwhile, the concrete under your feet, poured in the 1970s, is already crumbling. Engineers are spending $191 billion just to patch the nation's bridges. Every single year, almost half of them inch past their maximum design life. We did not lose the ability to build like the Romans by accident. We lost it because a material that lasts 2,000 years cannot be sold twice. This is the story of the recipe that built an empire, survived earthquakes, volcanoes, and 2,000 years of crashing seawater, and was quietly replaced by an industry that needed you to keep buying. Welcome to Nature's Lost Vault. The archive opens in Rome, 27 BC. A new emperor has just taken power. His name is Augustus, and he wants to build a city that will outlast history itself. He commissions his engineers to standardize the imperial concrete mix. They select a specific volcanic ash from the Alban Hills southeast of Rome, a deposit called red pozzolana, and Augustus decrees it the official material of Roman construction. That single decision would echo for 20 centuries. The recipe was first written down by a military engineer named Marcus Vitruvius Pollio. His 10-volume work, De Architectura, described a mortar of volcanic ash, quicklime, and seawater, packed against volcanic rock and left to cure. Vitruvius noted that structures built this way were impregnable to the waves and every day stronger. Nobody took that phrase literally for 2,000 years. They should have. By 128 AD, under Emperor Hadrian, the Pantheon was complete. Its concrete dome spans 142 feet. It contains no steel reinforcement. It has never been repaired, and it has not moved a fraction of an inch in nearly 1,900 years. It is not a ruin. It is a functioning building. The Romans also built massive harbor walls and breakwaters from this same concrete, structures submerged in the Mediterranean, battered by salt water and brutal storms for 20 centuries. Many still stand. When modern concrete is exposed to seawater, it begins to dissolve within decades. When Roman concrete is submerged in seawater, it actually gets stronger. For most of modern history, no one understood why. Scientists assumed the key was the volcanic ash, but the real secret was something engineers had been staring at for generations and arrogantly written off as a mistake. When researchers examined fragments of Roman concrete under microscopes, they kept finding the exact same anomaly: small, bright white lumps scattered throughout the mix. For decades, the assumption was that Roman builders were sloppy. Modern experts believed they had not mixed their mortar properly, and that these lumps were evidence of poor quality control. Then, in January 2023, a team led by MIT professor Admir Masic published a landmark study in the journal Science Advances. They had spent close to a decade analyzing Roman concrete samples from the archaeological site of Privernum, Italy. What they found changed the entire history of engineering. Those white lumps were not accidents. They were the entire point. The Romans were not using slaked lime, the safe diluted form that historians had always assumed. They were using quicklime, the raw, highly caustic form, mixed directly with volcanic ash at extreme heat. The resulting concrete was violently reactive and dangerously hot to work with. But as it cooled and cured, something extraordinary happened. The quicklime did not fully dissolve. It formed tiny concentrated reservoirs of reactive calcium throughout the entire structure, distributed evenly, waiting. When a microscopic crack forms in Roman concrete, whether from an earthquake, from centuries of settling, or from extreme thermal expansion, water seeps in. But when that water touches the hidden calcium reservoirs, a chemical reaction is triggered. New calcium carbonate crystals begin to grow inside the fracture. The crack seals itself. The concrete repairs its own damage. Automatically, without a single human intervention. In marine environments, this self-healing goes even further. As seawater percolates through Roman harbor walls, it reacts with the volcanic ash and limestone to form a rare crystal called aluminous tobermorit. This crystal does not weaken the structure. It binds it, making it harder, denser, and more resistant to fracture with every passing decade. The Roman scholar Pliny the Elder described these sea walls as a single stone mass, impregnable to the waves, and every day stronger. He wrote that in 79 AD, he was describing a dynamic chemical process that science would not fully understand for nearly 2,000 years. So how was this miracle erased? When the Western Roman Empire collapsed in 476 AD, the vast imperial supply chains that shipped red pozzolana from the Bay of Naples to construction sites across Europe and the Middle East broke down. Builders substituted. They improvised. The fundamental chemistry of the hot mixing technique, the secret of the quicklime reservoirs, was never fully documented in a way that survived the collapse. The recipe degraded, and then it vanished entirely. For over 1,300 years, no one built like the Romans. Then, in 1824, a British bricklayer named Joseph Aspdin burned powdered limestone and clay in his kitchen oven and called the result Portland cement. It set fast, and it was cheap to produce. It reached working strength in days instead of months. Within decades, it swept across the industrializing world. By the 1920s, the Portland Cement Association had embedded a staff of 125 engineers into state highway departments and city planning offices across America. They demonstrated fast-curing concrete roads, promoted their proprietary specifications, and helped write the building standards that would govern American construction for the next century. Traditional lime-based mortars, the standard in American masonry since the colonial era, were systematically written out of the code. Portland cement was stronger, faster, and could be manufactured at massive industrial scale and sold by the megaton. But what no one calculated was the long-term cost. Modern Portland cement is designed for speed. That speed creates immense internal stress. As it cures, it shrinks, forming thousands of invisible micro-cracks. Those cracks let in water. To give modern concrete tensile strength, we fill it with steel rebar. When the water reaches that steel, the rebar rusts. As it rusts, it expands up to 4 times its original size, literally blowing the concrete apart from the inside out. It is an infrastructure death sentence built directly into the chemistry. A typical modern concrete bridge is engineered to last 50 years. The Pantheon is 1,897 years old and has never needed structural repair. America currently faces a $3.7 trillion infrastructure gap, bleeding thousands of dollars from every household in lost time, vehicle damage, and endless highway patching. A material that built harbors meant to last forever was replaced by a material that guarantees perpetual repair. One generates revenue once, the other is a subscription model disguised as engineering. When MIT published its 2023 study Decoding the Self-Healing Secret, the response from the construction industry was polite interest. No government mandate, no building code revision, no industry-wide adoption, because the Portland cement industry produces 4.4 billion tons of material annually. It is the third most manufactured substance on Earth. A concrete that lasts 10 times longer, heals its own cracks, and does not need perpetual replacement, does not serve a $300 billion global industry. It threatens it. But the knowledge is out. The recipe, misread for 2,000 years, has been decoded by some of the best materials scientists alive. And the raw materials are not patented. Volcanic ash deposits exist across the American West. Quicklime is sold at local building supply stores. The hot mixing technique requires no specialized equipment. If you want to step outside the Portland cement monopoly today, you already can. Natural hydraulic lime, NHL, is commercially available and produces a mortar with properties similar to ancient Roman formulations. It breathes, flexes, and seals hairline cracks without shattering. It is the only material that should ever be used to repoint historic brick homes. Modern Portland cement mortar is harder than the surrounding brick. When thermal pressure builds, it is not the mortar that cracks. It is the brick. Entire facades on buildings from before 1920 are being destroyed by the wrong repair material, applied by contractors who were never taught the difference. The next time you sit in traffic on a crumbling overpass, or dodge a pothole on a highway that was repaved just 5 years ago, you will know something that most engineers alive today have not yet acted on. There is a building in Rome that is 1,897 years old, with a concrete dome that has never once needed what those bridges need every decade. The Romans did not build for quarterly profit cycles. They built for permanence. That philosophy cannot be sold on a recurring basis, so it was replaced by one that can. The recipe is not lost anymore. It is waiting for builders willing to remember what permanence actually costs and what it saves. If this vault opened something for you, subscribe to Nature's Lost Vault and hit the bell. Every like and every share preserves what they tried to erase. The next vault opens soon.